Good morning, fellow Form 4 students. And it's been pretty long. We have not been in class, and each and every one of you is really feeling bored. But Corona will soon be over, and we shall go back to our classrooms again. All we need to do is maintain good hygiene, keep our environments clean, and wash our hands very well, and avoid close contact with people. Okay, that notwithstanding, we ended last term with Cartesian product and ways of representing relations. So today, before we actually start our lesson, we shall begin with the Cartesian product. And to actually start with Cartesian product, I'm going to put 2 or 3 problems on Cartesian product and on how to also represent relations for us to revise and start with it. And after that, we'll go to our lesson proper. Now we'll begin with Cartesian product. If I have a set A, because we have 1, 2, and another set B, because small a, small b, the Cartesian product between A and B is always denoted A cross B, and A cross B. Here, like I said, you are going to form ordered pairs. So you take the first element in A and you map it with the second element in B. You do the same with the first element in A and the second in B. When you are done with the first element in A, you now go to the second element in A. So the first element in A now is 1, which is paired with small a, comma. Then you take the first element again, 1, and you pair it with small b, that's the second element. We are done with 1. Now we shall go to 2. So we're going to take 2 and pair 2 with A. After that, we take 2 and pair 2 with B. Once this is done, then that is what we call a Cartesian product, because the Cartesian product is a combination of ordered pairs. So we combine so many ordered pairs, it forms what we call the Cartesian product. Now let us go to ways of representing our relations. I said for us to actually represent relations, we can use arrow diagrams. And these arrow diagrams is simply a combination of oval shapes. Oval shapes are shapes like this. It looks like an egg, but it's not an egg. So with these oval shapes, we always have 2 of them. The first one is always called the domain, and the second one is called the codomain. So now, arrows will be moving from domain to the codomain, or from the codomain to the domain, based on the nature of the equation. So I can label the domain data A and the codomain data B, and I state my relation. That is what we did in the last class. And I said if we have 2 sets and a relation is half of, let's say is half of, that's my relation, it's half of, put it in quotes, and we say A has elements 2, 4, 6, and 8, and B has elements 4, 8, 12, 15, 16, then we shall link the elements from set A to set B based on the relation we have above. We discovered 2 is half of 4. I'll link them up with an arrow. Look at the way I'm doing it. The arrowheads must be indicated very well to show that we are moving from set 1 to set 2. Now, we move to the next element. 4 is half of 8. I'll link it like that. Now, ask the question, is 2 half of 8? No, 2 is not half of 8. That's why I cannot link 2 to 8. We'll go to the next. 6 is half of 12. Next, 8 is 8 half of 15. Those are the kind of things we need to actually verify. 8 is not half of 15. So now we are going to take 8 and we map it to 16, because 8 is half of 16. Alright, that is that about what we have, what we demonstrated in the last class. And since we have this in mind, okay, I'm going to now give you an activity where you will be the one to draw the arrow diagrams and using a given relation for us to actually go through what we have done to see if you have a mastery of the concept. All right. Now we wish to look at this activity, and the activity is talking about two sets. I'm going to read it for you to actually follow what is happening. So consider the set m equals 1, 2, 3, and n equals 4, 6. Those are the two given sets. The question is for you to draw an arrow diagram to represent the sets m and n using the relation is a factor of. I already explained what factors are in the last class. So you're going to use the relation is a factor of, then you draw the oval shapes, you indicate the domain, the codomain, and you link them up using arrows. So if A is a factor of B, then you connect. If A is not a factor of B, don't connect. This is what we did in our last lesson. So our lesson of today is mathematical relations. Mathematical relations here simply means how variables are linked to one another. Recall, even at home, we have relationships. We have relationships that exist between our parents, our brothers and sisters, and so on. It's the same thing we are going to do here. The real life situation here is where we are related to our cousins, nephews, aunties, uncles, nieces, and so on. So it's the same thing that applies. And there exist basically 4 types of relations. The very first one is a one-to-one relation. A one-to-one relation here is that type of relation where one element in the domain is mapped to one and only one element in the codomain. When one element in the domain is mapped to one and only one element in the codomain, it now forms what we call a one-to-one relation. If you look at your notes, you will see I've given the definition and there is an example. An example on that is we have a relation is 1/4 of, that is my relation, is 1/4 of. So you are saying that if y is equal to 4x, then discover that x is y over 4. This is my domain. This is my domain. The first oval shape is my domain. And now that I have the first oval shape as my domain, we discover that my arrows now are moving from the domain A to the codomain B, and I'm using my relation is 1/4 of. So 1 is 1/4 of 8, 2 is 1 is 1/4 of 4, 2 is 1/4 of 8, and 3 is 1/4 of 12. So if you take 1/4 of 12, you have 3. You take 1/4 of 8, you have 2. You take 1/4 of 4, you have 1. So that is the relation and the diagrammatic representation. So here you discover that here is 1-to-1. One element from the domain is mapped to one and only one element in the codomain. When that is done, we'll now conclude that we're dealing with a one-to-one relation. So I believe that all of us are there and we'll continue. Okay, we are set for one-to-one relation. Now let us go to many-to-one relation. It means so many elements from the domain is mapped to one and only one element in the codomain. That is the definition. So here we are going to use the names of some of our students to demonstrate that relationship. Look at what happens. If I consider relation is a friend to, we have the first set. A has the elements Etame, Keyan, Susan, and Annie. Set B has Melissa and Emilio. Our problem here is that we need to come up with oval shapes and the relation we have above, and we come up with the arrows. So we have a relation above is a friend to. We have our set, so we'll draw our shapes and link them with respect to the given relation. So we have the relation is A is a friend to B. So if that exists, then we have to first of all come up with the oval shape for the first set A. If you look at the board, you discover that my domain has element Etame, Keyan, Susan, and Annie. That's my domain. Then my codomain has Melissa and Emilio. That's my codomain. Now I need to cross them. Etame is a friend to Emilio. Keyan is a friend to Emilio. But Susan and Annie are not friends to Emilio. Then now go to the next. Discover that Susan is a friend to Melissa. Annie is a friend to Melissa, but they are not friends to Emilio. So you look at the way the arrows are moving. The arrows are simply linking them with respect to the relationship that exists between them. And that's it. Okay, finally, we will look at our activity. That is what you will do for me. We have our activity. Let's say for each of the relations below, defined between the set X. You see, it is specified. X is a domain. And y here is the codomain. They say draw arrow diagrams to represent these relations and identify the type. We have treated just two types. We have one-to-one relation and the many-to-one. So you are going to draw arrow diagrams using the domain and the codomain and the relation given to you, and you identify the type of relation. The first activity is less than or equal to. So set x here has elements 1, 2, set y has elements 1, 2, 3. Then this way, we need to use the relation is less than and come out with our result. Recall we are told that x is the domain and y is the codomain. Then we go to the next question that says is a square of, or square root of, sorry, is a square root of. So now x is my domain and y is my codomain. So I'm going to draw the two oval shapes and I link elements from the domain to the codomain based on the relationship given to me. After that, I will now conclude by doing what? Identifying the type of relation. So this is what you will take home. You will work with it, and then in our next class, I expect you to give me positive results. Once more again, you are welcome back from the short vacation you have. Let me put it that way. Don't worry, giving you work, and I'm so impressed that with this second phase we can now talk live. You can see me explaining, not just sending you questions and so on. We can now explain, and I wait for your questions. When you solve and you have difficulties, please make sure when I'm online you ask questions and I will respond immediately. It's been a pleasure working with you guys, and I pray that you guys should stay blessed and keep good hygienic condition, please. Have a nice day.